Chandrayaan-1, Telugu, Sanskrit, Chandrayaana, was India's first unmanned lunar probe. It was launched by the Indian Space Research Organisation in October 2008, and operated until August 2009. The mission included a lunar orbiter and an impactor. India launched the spacecraft using a PSLV-XL rocket, serial number C11, on October 22, 2008 from Satish Dhawan Space Centre, Sriharikota, Nellore District, Andhra Pradesh, about 80 km north of Chennai, at 6:22 IST. Former Prime Minister Atal Bihari Vajpayee announced the project on course in his Independence Day speech on August 15, 2003. The mission was a major boost to India's space program, as India researched and developed its own technology in order to explore the Moon. The vehicle was successfully inserted into lunar orbit on November 8, 2008. On November 14, 2008, the Moon impact probe separated from the Chandrayaan orbiter at 20:06 and struck the South Pole in a controlled manner, making India the fourth country to place its flag on the Moon. The probe impacted near the crater Shackleton at 2031, ejecting underground soil that could be analyzed for the presence of lunar water ice. The estimated cost for the project was $3.86 billion. The remote sensing lunar satellite had a mass of 1,380 kilograms at launching 675 kilograms in lunar orbit. It carried high-resolution remote sensing equipment for visible, near-infrared, and soft and hard X-ray frequencies. Over a 2-year period, it was intended to survey the lunar surface to produce a complete map of its chemical characteristics and three-dimensional topography. The polar regions are of special interest as they might contain ice. The lunar mission carried 5 ISRO payloads and 6 payloads from other space agencies including NASA, ESA, and the Bulgarian Aerospace Agency, which were carried free of cost. After suffering from several technical issues including failure of the star sensors and poor thermal shielding, Chandrayaan stopped sending radio signals at 1:30 IST on August 29, 2009, shortly after which, the ISRO officially declared the mission over. Chandrayaan operated for 312 days as opposed to the intended 2 years, but the mission achieved 95% of its planned objectives. Among its many achievements was the discovery of the widespread presence of water molecules in lunar soil. Objectives: the mission had the following stated scientific objectives: to design, develop, launch and orbit a spacecraft around the Moon using an Indian-made launch vehicle, to conduct scientific experiments using instruments on the spacecraft which would yield data, for the preparation of a three-dimensional atlas of both the near and far sides of the Moon, for chemical and mineralogical mapping of the entire lunar surface at high spatial resolution, mapping particularly the chemical elements magnesium, aluminium, silicon, calcium, iron, titanium, radon, uranium, and thorium, to increase scientific knowledge, to test the impact of a sub-satellite on the surface on the Moon as a forerunner to future soft landing missions. Specifications: mass, 1,380 kg at launch, 675 kg at lunar orbit, and 523 kg after releasing the impactor. Dimensions: cuboid in shape of approximately 1.5 am, communications, X-band, 0.7 am diameter dual gimbaled parabolic antenna for payload data transmission. The telemetry, tracking and command communication operates in S-band frequency. Power: the spacecraft was mainly powered by its solar array, which included one solar panel covering a total area of 2.15 x 1.8 am, generating 750 AW of peak power, which was stored in a 36Ah lithium-ion battery for use during eclipses. Propulsion: the spacecraft used a bit propellant integrated propulsion system to reach lunar orbit as well as orbit and altitude maintenance while orbiting the Moon. The power plant consisted of one 440 newtons engine and 8 22N thrusters. Fuel and oxidizer were stored in 2 tanks of 390 liters each. Navigation and control: the craft was 3-axis stabilized with 2 star sensors, gyros and 4 reaction wheels. The craft carried dual redundant bus management units for attitude control, sensor processing, antenna orientation, etc. Specific areas of study: high-resolution mineralogical and chemical imaging of the permanently shadowed north and south polar regions, searching for surface or subsurface lunar water ice, especially at the lunar poles, identification of chemicals in lunar highland rocks, chemical stratigraphy of the lunar crust by remote sensing of the central uplands of large lunar craters, and of the South Pole Aitken region, an expected site of interior material, mapping the height variation of features of the lunar surface, observation of X-ray spectrum greater than 10 keV and stereographic coverage of most of the Moon's surface with 5 m resolution, providing new insights in understanding the Moon's origin and evolution. Payload: the scientific payload had a total mass of 90 kg and contained 5 Indian instruments and 6 instruments from other countries. Indian instruments: TMC or the terrain mapping camera is a CMOS camera with 5 am resolution and a 40 km swath in the panchromatic band and was used to produce a high-resolution map of the Moon. The aim of this instrument was to completely map the topography of the Moon. The camera works in the visible region of the electromagnetic spectrum and captures black and white stereo images. When used in conjunction with data from Lunar Laser Ranging Instrument, it can help in better understanding of the lunar gravitational field as well. TMC was built by the ISRO's Space Applications Center at Ahmedabad. The TMC was successfully tested on October 29, 2008 through a set of commands issued from a STRARC. HYC or hyperspectral imager is a CMOS camera, performed mineralogical mapping in the 400-900 nm band with a spectral resolution of 15 nm and a spatial resolution of 80 am. LLRI or Lunar Laser Ranging Instrument determines the height of the surface topography by sending pulses of infrared laser light towards the lunar surface and detecting the reflected portion of that light. It operated continuously and collected 10 measurements per second on both the day and night sides of the Moon. LLRI was developed by Laboratory for Electro-Optic Systems of ISRO, Bangalore. It was successfully tested on November 16, 2008. HEX is a high-energy large gamma X-ray spectrometer for 30 AA-200 keV measurements with ground resolution of 40 km. The HEX measured U.Th. 210 Pb, 222 Rnd gassing, and other radioactive elements. MIP or the Moon Impact Probe developed by the ISRO, is an impact probe which consisted of a C-band radar altimeter for measurement of altitude of the probe, a video imaging system for acquiring images of the lunar surface and a mass spectrometer for measuring the constituents of the lunar atmosphere. It was ejected at 20:00 IST on November 14, 2008. The Moon Impact Probe successfully crash-landed at the lunar South Pole at 20:31 IST on November 14, 2008. It carried with it a picture of the Indian flag. India is now the fourth nation to place a flag on the Moon after the Soviet Union, United States and Japan. Instruments from other countries: C1XS or X-ray fluorescence spectrometer covering 1-10 keV, mapped the abundance of Mg, Al, C, Ca, T, and Fe at the surface with a ground resolution of 25 km, and monitored solar flux. This payload results from collaboration between Rutherford Appleton Laboratory, UK, ESA and ISRO. It was activated on November 23, 2008. SARA, the sub-keV atom reflecting analyzer from the ESA mapped mineral composition using low-energy neutral atoms emitted from the surface. M3, the Moon Mineralogy Mapper from Brown University and JPL is an imaging spectrometer designed to map the surface mineral composition. It was activated on December 17, 2008. SIR2, a near-infrared spectrometer from ESA, built at the Max Planck Institute for Solar System Research, Polish Academy of Science and University of Bergen, also mapped the mineral composition using an infrared grating spectrometer. The instrument is similar to that of the SMART 1 SIR. It was activated on November 19, 2008 and scientific observations were successfully started on November 20, 2008. Mini-SAR, designed, built and tested for NASA by a large team that includes the Naval Air Warfare Center, Johns Hopkins University Applied Physics Laboratory, Sandia National Laboratories, Raytheon and Northrop Grumman. Mini-SAR is the active synthetic aperture radar system to search for lunar polar ice. The instrument transmitted right polarized radiation with a frequency of 2.5 GHz and monitored scattered left and right polarized radiation. The Fresnel reflectivity and the circular polarization ratio are the key parameters deduced from these measurements. ICE shows the coherent backscatter opposition effect which results in an enhancement of reflections and CPR, so that water content of the Moon's polar regions can be estimated. RADOM-7, Radiation Dose Monitor experiment from the Bulgarian Academy of Sciences maps the radiation environment around the Moon. It was successfully tested on November 16, 2008. Mission timeline: Chandrayaan-1 was launched on October 22, 2008 at 6:22 a.m. IST from Satish Dhawan Space Centre using the ISRO's 44.4-metre-tall four-stage PSLV launch rocket. Chandrayaan-1 was sent to the Moon in a series of orbit-increasing maneuvers around the Earth over a period of 21 days as opposed to launching the craft on a direct trajectory to the Moon. At launch the spacecraft was inserted into geostationary transfer orbit with an apogee of 22,860 km and a perigee of 255 km. The apogee was increased with a series of 5 orbit burns conducted over a period of 13 days after launch. For the duration of the mission, ISRO's telemetry, tracking and command network at Payenya in Bangalore, tracked and controlled Chandrayaan-1. Scientists from India, Europe, and the US conducted a high-level review of Chandrayaan-1 on January 29, 2009 after the spacecraft completed its first 100 days in space. Earth orbit burns: first orbit burn. The first orbit-raising maneuver of Chandrayaan-1 spacecraft was performed at 9 hours IST on October 23, 2008 when the spacecraft a Euro-1 registered trademark S440 Newton liquid engine was fired for about 18 minutes by commanding the spacecraft from Spacecraft Control Center at ISRO Telemetry, Tracking and Command Network at Payenya, Bangalore. With this Chandrayaan-1 a Euro-1 registered trademark S apogee was raised to 37,900 km, and its perigee to 305 km. In this orbit, Chandrayaan-1 spacecraft took about 11 hours to go around the Earth once. Second orbit burn: the second orbit-raising maneuver of Chandrayaan-1 spacecraft was carried out on October 25, 2008 at 5:48 IST when the spacecraft a Euro-1 registered trademark S engine was fired for about 16 minutes, raising its apogee to 74,715 km, and its perigee to 336 km, thus completing 20% of his journey. In this orbit, Chandrayaan-1 spacecraft took about 25.5 hours to go round the Earth once. This is the first time an Indian spacecraft has gone beyond the 36,000 km high geostationary orbit and reached an altitude more than twice that height. Third orbit burn: the third orbit-raising maneuver was initiated on October 26, 2008 at 7:08 IST when the spacecraft a Euro-1 registered trademark S engine was fired for about 9.5 minutes. With this its apogee was raised to 164,600 km, and the perigee to 348 km. In this orbit, Chandrayaan-1 took about 73 hours to go around the Earth once. Fourth orbit burn: the fourth orbit-raising maneuver took place on October 29, 2008 at 7:38 IST when the spacecraft's engine was fired for about 3 minutes, raising its apogee to 267,000 km and the perigee to 465 km. This extended its orbit to a distance more than half the way to the Moon. In this orbit, the spacecraft took about 6 days to go around the Earth once. Final orbit burn: the fifth and final orbit-raising maneuver was carried out on November 4, 2008 at 4:56 a.m. IST when the spacecraft a Euro-1 registered trademark S engine was fired for about 2.5 minutes resulting in Chandrayaan-1 entering the lunar transfer trajectory with an apogee of about 380,000 km. Lunar orbit insertion: Chandrayaan-1 successfully completed the lunar orbit insertion operation on November 8, 2008 at 16:51 IST. This maneuver involved firing of the liquid engine for 817 seconds when the spacecraft passed within 500 km from the Moon. The satellite was placed in an elliptical orbit that passed over the polar regions of the Moon, with 7502 km aposelene and 504 km periselene. The orbital period was estimated to be around 11 hours. With the successful completion of this operation, India became the sixth nation to put a vehicle in lunar orbit. First lunar orbit reduction maneuver of Chandrayaan-1 was carried out successfully on November 9, 2008 at 20:03 IST. During this, the engine of the spacecraft was fired for about 57 seconds. This reduced the periselene from 504 km to 200 km while aposelene remained unchanged at 7502 km. In this elliptical orbit, Chandrayaan-1 took about 10.5 hours to circle the Moon once. Second orbit reduction, this maneuver was carried out on November 10, 2008 at 21:58 IST, resulting in steep decrease in Chandrayaan-1 a unregistered trademark S aposelene from 7502 km to 255 km and its periselene from 200 km to 187 km. During this maneuver, the engine was fired for about 866 seconds. Chandrayaan-1 took 2 hours and 16 minutes to go around the Moon once in this orbit. Third lunar orbit reduction was carried out by firing the onboard engine for 31 seconds on November 11, 2008 at 18:30 IST. This reduced the periselene from 187 km to 101 km, while the aposelene remained constant at 255 km. In this orbit Chandrayaan-1 took 2 hours and 9 minutes to go around the Moon once. Final orbit, Chandrayaan-1 spacecraft was successfully placed into a mission-specific lunar polar orbit of 100 km above the lunar surface on November 12, 2008. In the final orbit reduction maneuver, Chandrayaan-1 a unregistered trademark S aposelene was reduced from 255 km to 100 km while the periselene was reduced from 101 km to 100 km. In this orbit, Chandrayaan-1 takes about 2 hours to go around the Moon once. 2 of the 11 payloads the terrain mapping camera and the radiation dose monitor have already been successfully switched on. The TMC successfully acquired images of both the Earth and the Moon. Impact of the MIP on the lunar surface. The Moon Impact Probe crash-landed on the lunar surface on November 14, 2008, 15:01 UTC, near the crater Shackleton at the South Pole. The MIP was one of 11 scientific instruments on board Chandrayaan-1. The MIP separated from Chandrayaan at 1:00 km from lunar surface and began its nosedive at 14:36 UTC, going into free fall for 30 minutes. As it fell, it kept sending information back to the mother satellite which, in turn, beamed the information back to Earth. The altimeter then also began recording measurements to prepare for a rover to land on the lunar surface during a second Moon mission planned for 2017. Following the successful deployment of the MIP, the other scientific instruments were turned on, starting the next phase of the mission. After scientific analyses of the received data from the MIP, the Indian Space Research Organisation confirmed the presence of water in the lunar soil and published the finding in a press conference addressed by its then-chairman G. Madhavan Nair. Rise of spacecraft's temperature. ISRO had reported on November 25, 2008 that Chandrayaan-1's temperature had risen above normal to 50 degrees Celsius. Scientists said that it was caused by higher than normal temperatures in lunar orbit. The temperature was brought down by about 10 degrees Celsius by rotating the spacecraft about 20 degrees and switching off some of the instruments. Subsequently ISRO reported on November 27, 2008 that the spacecraft was operating under normal temperature conditions. In subsequent reports ISRO says, since the spacecraft was still recording higher than normal temperatures, it would be running only one instrument at a time until January 2009 when lunar orbital temperature conditions are said to stabilize. The spacecraft was experiencing high temperature because of radiation from the Sun and infrared radiation reflected by the Moon. Mapping of minerals. The mineral content on the lunar surface was mapped with the Moon Mineralogy Mapper, a NASA instrument on board the orbiter. The presence of iron was reiterated and changes in rock and mineral composition have been identified. The Oriental Basin region of the Moon was mapped, and it indicates abundance of iron-bearing minerals such as pyroxene. Mapping of Apollo landing sites. ISRO announced in January 2009 the completion of the mapping of the Apollo Moon mission's landing sites by the orbiter, using multiple payloads. 6 of the sites have been mapped, including that of Apollo 11, the first mission that brought humans on the Moon. Images acquisition. The craft completed 3,000 orbits, acquiring 70,000 images of the lunar surface, which many in ISRO believe is quite a record compared to the lunar flights of other nations. ISRO officials estimated that if more than 40,000 images have been transmitted by Chandrayaan's cameras in 75 days, it worked out to nearly 535 images being sent daily. They were first transmitted to Indian Deep Space Network at Byalalu near Bangalore, from where they were flashed to ISRO's telemetry tracking and command network at Bangalore. Some of these images have a resolution of down to 5 meters, providing a sharp and clear picture of the Moon's surface, while many images sent by some of the other missions had only a 100-meter resolution. On November 26, the indigenous terrain mapping camera, which was first activated on October 29, 2008, acquired images of peaks and craters. This came as a surprise to ISRO officials because the Moon consists mostly of craters. Detection of X-ray signals. The X-ray signatures of aluminium, magnesium and silicon were picked up by the C1XS X-ray camera. The signals were picked up during a solar flare that caused an X-ray fluorescence phenomenon. The flare that caused the fluorescence was within the lowest C1XS sensitivity range. Full Earth image. On March 25, 2009, Chandrayaan beamed back its first images of the Earth in its entirety. These images were taken with the TMC. Previous imaging was done on only one part of the Earth. The new images show Asia, parts of Africa and Australia, with India being in the center. Orbit raised to 200 km due to malfunctions. After the completion of all the major mission objectives, the orbit of Chandrayaan-1 spacecraft, which was at a height of 100 km from the lunar surface since November 2008, had to be raised to 200 km due to malfunctions. The orbit-raising maneuvers were carried out between 0900 and 1000 IST on May 19, 2009. The spacecraft in this higher altitude enabled further studies on orbit perturbations, gravitational field variation of the Moon, and also enabled imaging lunar surface with a wider swath. However, it was later revealed that the true reason for the orbit change was that it was an attempt to keep the temperature of the probe down. It was assumed that the temperature of the spacecraft subsystems at 100 km above the Moon's surface would be around 75 degrees Celsius. However, it was more than 75 degrees and problems started to surface. We had to raise the orbit to 200 km, attitude sensor failure. The star sensors, a device used for pointing attitude determination, failed in orbit after 9 months of operation. Afterward, the orientation of Chandrayaan was determined using a backup procedure using a 2-axis sun sensor and taking a bearing from an Earth station. This was used to update 3-axis gyroscopes, which enabled spacecraft operations. The second failure, detected on May 16, was attributed to excessive radiation from the Sun. Radar scans. On August 21, 2009, Chandrayaan-1 along with the Lunar Reconnaissance Orbiter attempted to perform a bistatic radar experiment using their mini-SAR radars to detect the presence of water ice on the lunar surface. The attempt was a failure. It turned out the Chandrayaan-1 radar was not pointed at the Moon during the experiment. The mini-SAR has imaged many of the permanently shadowed regions that exist at both poles of the Moon. On March 2010, it was reported that the mini-SAR on board the Chandrayaan-1 had discovered more than 40 permanently darkened craters near the Moon's north pole, which are hypothesized to contain an estimated 600 million metric tons of water ice. The radar's high CPR is not uniquely diagnostic of either roughness or ice. The science team must take into account the environment of the occurrences of high CPR signal to interpret its cause. The ice must be relatively pure and at least a couple of meters thick to give this signature. The estimated amount of water ice potentially present is comparable to the quantity estimated from the previous mission of Lunar Prospector's neutron data. Although the results are consistent with recent findings of other NASA instruments on board Chandrayaan-1 discovered water molecules in the Moon's polar regions, while water vapor was detected by NASA's Lunar Crater Observation and Sensing Satellite, or LCROSS, this observation is not consistent with the presence of thick deposits of nearly pure water ice within a few meters of the lunar surface, but it does not rule out the presence of small, discrete pieces of ice mixed in with the regolith. End of the mission. The mission was launched on October 22, 2008 and expected to operate for 2 years. However, at 09:02 on August 29, 2009 communication with the spacecraft was suddenly lost. The probe had operated for 312 days. The craft was expected to remain in orbit for approximately another 1,000 days, eventually crashing into the lunar surface. A member of the Science Advisory Board of Chandrayaan-1 said that it is difficult to ascertain reasons for the loss of contact. ISRO Chairman Madhavan Nair said that due to very high radiation, power supply units controlling both the computer systems on board failed, snapping the communication connectivity. However, information released later showed that the power supply supplied by MDI failed due to overheating. Completion of primary objectives. Although the mission was less than 10 months in duration, and less than half the intended 2 years in length, a review by scientists termed the mission successful, as it had completed 95% of its primary objectives, consisting of, to construct the complex spacecraft with 11 scientific instruments, to place the spacecraft in a circular orbit around the Moon by orbit-raising maneuvers from a near-Earth orbit, to place the flag of India on the Moon, to carry out imaging operations and to collect data on the mineral content of the lunar soil, to set up a deep space tracking network and implement the operational procedures for travel into deep space. The data collected from the mission have been disseminated to Indian scientists and also the partners from Europe and USA for analysis. Data collected analysis result, Chandrayaan's moon mineralogy mapper has confirmed the magma ocean hypothesis, meaning that the Moon was once completely molten. The terrain mapping camera on board Chandrayaan-1, besides producing more than 70,000 three-dimensional images, has recorded images of the landing site of U.S. spacecraft Apollo 15, rubbishing conspiracy theories that the U.S. mission to land on the Moon 4 decades back was a hoax. TMC and HYC payloads of ISRO have covered about 70% of the lunar surface, while M3 covered more than 95% of the same, and SIR-2 has provided high-resolution spectral data on the mineralogy of the Moon. Indian Space Research Organisation said interesting data on lunar polar areas was provided by Lunar Laser Ranging Instrument and High-Energy X-ray Spectrometer of ISRO as well as miniature synthetic aperture radar of the USA. LLRI covered both the lunar poles and additional lunar regions of interest. HEX made about 200 orbits over the lunar poles, and Mini-SAR provided complete coverage of both north and south polar regions of the Moon. Another ESA payload, a Chandrayaan-1 imaging X-ray spectrometer, detected more than 24 weak solar flares during the mission duration. The Bulgarian payload called Radiation Dose Monitor was activated on the day of the launch itself and worked until the mission's end. ISRO said scientists from India and participating agencies expressed satisfaction on the performance of Chandrayaan-1 mission as well as the high quality of data sent by the spacecraft. They have started formulating science plans based on the datasets obtained from the mission. It is expected that in the next few months, interesting results about lunar topography, mineral and chemical contents of the Moon and related aspects are expected to be published. The Chandrayaan-1 payload has enabled scientists to study the interaction between the solar wind and a planetary body like the Moon without a magnetic field. In its 10-month orbit around the Moon, Chandrayaan-1, a unregistered trademark X-ray spectrometer detected titanium, confirmed the presence of calcium, and gathered the most accurate measurements yet of magnesium, aluminium and iron on the lunar surface. Lunar water discovery. On September 24, 2009, Science magazine reported that the Moon Mineralogy Mapper on Chandrayaan-1 had detected water on the Moon. But, on September 25, 2009, ISRO announced that the MIP, another instrument on board Chandrayaan-1, had discovered water on the Moon just before impact and had discovered it 3 months before NASA's M3. The announcement of this discovery was not made until NASA confirmed it. M3 detected absorption features near 2.8 euro 3.0 AA micrometer on the surface of the Moon. For silicate bodies, such features are typically attributed to hydroxyl and/or water-bearing materials. On the Moon, a feature is seen as a widely distributed absorption that appears strongest at cooler high latitudes and at several fresh feldspar-thick craters. The general lack of correlation of this feature in sunlit M3 data with neutron spectrometer H abundance data suggests that the formation and retention of OH and H2O is an ongoing subficial process. OH2O production processes may feed polar cold traps and make the lunar regolith a candidate source of volatiles for human exploration. The Moon Mineralogy Mapper, an imaging spectrometer, was one of the 11 instruments on board Chandrayaan-1 that came to a premature end on August 29, 2009. M3 was aimed at providing the first mineral map of the entire lunar surface. Lunar scientists had discussed the possibility of water repositories for decades. They are now increasingly confident that the decades-long debate is over, a report says. The Moon, in fact, has water in all sorts of places. Not just locked up in minerals, but scattered throughout the broken-up surface, and, potentially, in blocks or sheets of ice at depth. The results from the Chandrayaan mission are also offering a wide array of watery signals. Lunar water production. According to European Space Agency scientists, hydrogen nuclei from solar winds are absorbed by the lunar regolith. An interaction between the hydrogen nuclei and oxygen present in the dust grains are expected to produce hydroxyl and water. SARA instrument developed by ESA and the Indian Space Research Organisation, was designed and used to study the Lunar Euro-1 registered trademark S surface composition and solar wind surface interactions. SARA Euro-1 registered trademark S results highlight a mystery: not every hydrogen nucleus is absorbed. 1 out of every 5 rebounds into space, combining to form an atom of hydrogen. Hydrogen shoots off at speeds of around 200 km per second and escapes without being deflected by the Lunar Euro-1 registered trademark S weak gravity. This knowledge provides timely advice for scientists who are readying ESA Euro-1 registered trademark S Bepi Colombo mission to Mercury, as that spacecraft will carry 2 instruments similar to SARA. Lunar caves. Chandrayaan-1 discovered a large cave below the lunar surface. The tunnel, which was discovered near the lunar equator, is an empty volcanic tube, measuring about 2 kilometers in length and 360 meters in width. According to ASRIA, scientists SF of Ahmedabad-based Space Application Center, this could be a potential site for human settlement on the Moon. Earlier, Japanese lunar orbiter Kagai had also discovered a cave on Moon. Tectonism, data from the microwave sensor of the Chandrayaan-1 satellite processed using the image analysis software ENVI, has revealed a good amount of past tectonic activity on the lunar surface. The researchers think that the faults and fractures discovered could be features of past interior tectonic activity coupled with meteorite impacts. Awards for Chandrayaan-1. The American Institute of Aeronautics and Astronautics has selected ISRO's Chandrayaan-1 mission as one of the recipients of its annual AIAA Space 2009 Awards, which recognizes key contributions to space science and technology. The International Lunar Exploration Working Group chose the Chandrayaan-1 team for giving the International Cooperation Award. Dr. Milsamian Nadarai, Project Director, Chandrayaan-1. The Chandrayaan team of the Indian Space Research Organisation was chosen for the award for accommodation and tests of the most international lunar payload ever and the successful launch of the probe on PSLV rocket on October 22 and the lunar insertion of the spacecraft carried out subsequently. Team. The scientists considered instrumental to the success of the Chandrayaan-1 project are G. Madhavan Nair Chairman, Indian Space Research Organisation Drive TK Alex Director, ISAC Dr. Milsamian Nadir Project Director, Chandrayaan-1, SK Shiv Kumar Director Telemetry, Tracking and Command Network, Mr. M. Pichaimani Operations Director, Chandrayaan-1, Mr. Leo Jackson John Spacecraft Operations Manager, Chandrayaan-1, Dr. K. Radhakrishnan Director, VSSC, George Koshi Mission Director, PSLV-XL, Srinivasa Hegde Mission Director, Chandrayaan-1, Professor J. N. Goswami Director of Physical Research Laboratory and Principal Scientific Investigator of Chandrayaan-1, public release of data. Data gathered by Chandrayaan-1 was made available to the public by the end of the year 2010. The data was split into 2 seasons, with the first season going public by the end of 2010 and the second going public by the mid of 2011. The data contained rare pictures of the Moon and also data of chemical and mineral mapping of the lunar surface. Chandrayaan-2. ISRO is currently developing a second version of Chandrayaan named Chandrayaan-2, possibly to be launched in 2016. The Indian Space Research Organisation plans to include a robotic rover as a part of its second Chandrayaan mission. The rover will be designed to move on wheels on the lunar surface, pick up samples of soil or rocks, do on-site chemical analysis and send the data to the Earth via the Chandrayaan-2 orbiter, which will be orbiting the Moon. Lunar Outpost. Chandrayaan's imagery will be used to identify regions of interest that will be explored in detail by the NASA Lunar Reconnaissance Orbiter. The interest lies in identifying lunar water on the surface that can be exploited in setting up a future lunar outpost. The Mini-SAR, one of the U.S. payloads on Chandrayaan, was used to determine the presence of water ice. See also: Exploration of the Moon, ISRO Orbital Vehicle, List of artificial objects on the Moon, List of current and future lunar missions, List of Indian satellites, Lunar water. References. External links: Chandrayaan, ISRO Image Galleries, Pictures Spacecraft, Component and Ground Segment First Results, Official homepage of Chandrayaan-1, Chandrayaan Forum, Details of Chandrayaan from ISRO Publications,